For millions worldwide, pacemakers provide a life-sustaining rhythm, correcting irregular heartbeats and ensuring proper blood flow. Traditional pacemakers, while effective, come with inherent limitations. These devices, reliant on battery power and electrical leads, necessitate invasive surgical procedures for implantation and replacement. Moreover, their permanent presence in the body can lead to long-term complications such as infection, blood clots, and discomfort. Enter the revolutionary bioresorbable pacemaker, a game-changing innovation poised to transform the landscape of cardiac electrotherapy. Unlike their conventional counterparts, these devices are designed to naturally dissolve within the body after serving their purpose. This groundbreaking technology eliminates the need for surgical extraction, mitigates the risks associated with long-term implantation, and paves the way for a new era of patient care. The development of bioresorbable pacemakers represents a paradigm shift in medical device technology. By harnessing cutting-edge materials science and biomedical engineering, researchers have created a device that is both highly effective and completely biocompatible. This breakthrough holds immense promise for patients with heart conditions, offering a safer, less invasive, and ultimately more elegant solution for maintaining a healthy heart rhythm. Bioresorbable pacemakers operate on the same fundamental principles as traditional pacemakers, utilizing electrical impulses to regulate the heart's rhythm. However, their method of delivery and overall design represent a radical departure from conventional devices. Instead of relying on bulky batteries and electrical leads, these innovative pacemakers are powered wirelessly and constructed from specialized materials that naturally degrade over time. The core functionality of a bioresorbable pacemaker revolves around its ability to sense the heart's electrical activity and deliver precisely timed electrical impulses to maintain a consistent heartbeat. This is achieved through a miniaturized circuit implanted directly within the heart chamber. This circuit, powered wirelessly through an external transmitter, continuously monitors the heart's rhythm and delivers electrical stimulation only when necessary. Once the device has fulfilled its therapeutic role, its biodegradable components gradually break down into harmless substances that are naturally absorbed by the body. This eliminates the need for a second surgery to remove the device, reducing the risk of complications and improving the overall patient experience. The combination of wireless energy transfer and bioresorbable materials makes these pacemakers a truly revolutionary advancement in cardiac care. The success of bioresorbable pacemakers lies in their ingenious design and the utilization of cutting-edge materials. These devices are comprised of three key components: a miniaturized implantable circuit, an external energy transmitter, and a biocompatible biodegradable casing. The implantable circuit serves as the pacemaker's brain, housing the sensors, processing unit, and electrodes responsible for monitoring heart rhythm and delivering electrical impulses. This circuit is remarkably small, often no larger than a grain of rice, minimizing its footprint within the heart chamber. The external energy transmitter, typically worn as a small patch on the skin, wirelessly powers the implanted circuit through electromagnetic induction. This eliminates the need for bulky batteries within the device itself, further reducing its size and invasiveness. Encasing these delicate components is a biocompatible and biodegradable shell, typically made from specialized polymers or magnesium alloys. These materials are carefully chosen for their ability to harmlessly degrade within the body over a predetermined period, typically a few months to a year after the pacemaker has served its purpose. This controlled degradation ensures that the device effectively disappears from the body, leaving behind no permanent implants or the risk of long-term complications. Section 4. The advantages are clear. Biocompatibility and beyond. The advent of bioresorbable pacemakers brings forth a multitude of advantages over traditional pacemakers, ushering in a new era of patient-centric cardiac care. Their most significant benefit lies in their biocompatibility and biodegradability. Unlike permanent pacemakers, which can irritate surrounding tissues and trigger inflammatory responses, bioresorbable devices are designed to harmoniously integrate with the body. The materials used in their construction are carefully selected for their biocompatibility, minimizing the risk of adverse reactions or rejection by the immune system. Furthermore, their ability to naturally dissolve within the body eliminates the need for surgical extraction. a procedure often associated with complications such as infection, bleeding, and damage to surrounding tissues. Beyond biocompatibility, the absence of wires and batteries presents numerous advantages. Patients are spared the discomfort and potential complications associated with transvenous leads, such as vein occlusion and infection. The wireless design also grants patients greater freedom of movement and enhances overall comfort. Additionally, the temporary nature of bioresorbable pacemakers makes them particularly well suited for patients with transient heart conditions, such as those recovering from surgery or experiencing temporary heart block. Section 5. Biocompatible by design. Ensuring safety and effectiveness. Developing a device that can safely reside within the human body, interact with delicate cardiac tissues, and then harmlessly dissolve requires rigorous testing and meticulous material selection. Researchers meticulously evaluate the biocompatibility of every component of a bioresorbable pacemaker, ensuring they meet the highest standards of safety and efficacy. Material selection is paramount. Polymers used in the device's construction undergo extensive testing to evaluate their degradation rate, ensuring they break down into safe, biocompatible byproducts that the body can easily eliminate. The electrical components are encapsulated in biocompatible coatings to prevent direct contact with bodily fluids and minimize the risk of inflammation or adverse reactions. Furthermore, the device's surface is often modified to enhance biocompatibility and promote healthy tissue integration. These modifications may include coating the device with molecules that discourage scar tissue formation, or incorporating micropatterns that encourage cell adhesion and promote natural tissue regeneration. Through rigorous testing and meticulous design, researchers are ensuring that bioresorbable pacemakers are not only effective in treating heart conditions, but also safe and biocompatible throughout their lifespan within the body.
I'm sure you liked our video. We tried our best and we will continue to unleash the fun. Like and subscribe to encourage our work.